Digital video is always delivered in a compressed format. Whether you're watching the game in HD over digital cable, watching a DVD, or, hypothetically, watching a clip on the internet, you're watching compressed video. And more often than not, when you're watching compressed video, you're probably watching something that is loosely referred to as MPEG video. In this segment of TechKnow, we're going to dip into the history of MPEG, reveal how it works deep down, and talk about the future of digital video. MPEG is an acronym for Moving Picture Experts Group, which is a committee of the ISO/IEC that was established in 1988 to develop audio and video encoding standards. The group's work is incredibly important since it describes how digital audio and video are delivered and allows technologies such as digital cable and DVD movies to be universally accessible. The MPEG-1 standard was the first audio and video standard from the MPEG committee and was the basis of the video CD or VCD, which was the first digital disc-based format for movies. It is the most widely compatible MPEG format, so it is still in use, for example, in video for PowerPoint and on the web. Since the DVD video format has superseded the VCD, you might think that MPEG-1 is on the way out. But MPEG-1 audio lives on as songs in the MP3 format, which is really a contraction of MPEG-1 Audio Layer 3. All MPEG video up through the latest standards works in essentially the same way as MPEG-1 video does. There are two types of compression that occur: intra-frame compression and inter-frame compression. Intra, or within-frame compression, is easy to understand and familiar, even if the actual mathematics are a bit complex, since it's essentially the same as the digital compression used on still images and photos. The other way that MPEG video is digitally compressed is inter-frame, which is compression between different frames of video. Individual frames are compared to one another and duplicate information is removed. When one frame changes very little from the next, efficient MPEG encoding can save a lot of space. MPEG-2 is the next standard that came out of the committee and exploded onto the scene as DVD video, digital television, and satellite. While MPEG-1 video supported only a relatively small range of data rates, MPEG-2 is scalable and supports rates from 1.5 megabits per second to as high as 40 megabits per second, although you'll typically see data rates less than 9 megabits per second for DVD and a little less than that for digital cable. Inter-frame compression for MPEG-2 is quite interesting. Like other MPEG video standards, it involves three types of frames. I-frames, which are full frames using only intra-frame compression. P-frames, which are predictive frames that are generated based on the nearest previous I or P frame. And B-frames, which are bidirectional frames that use both past and subsequent frames as a reference. If you could look at an MPEG-2 stream as it was being decoded, you might initially find that only 1 in every 12 frames is actually visible. These are the I-frames, and they're not unlike the JPEG photos you see on the internet. As the stream is processed, the P-frames are calculated and rendered based on the nearest previous I-frame or P-frame. Finally, the B-frames would be calculated and rendered based on the nearest I and P frames. Like other MPEG standards, MPEG-2 is a patented and proprietary technology, which means that a licensing fee is required for usage. Although the fee is usually pretty small per user, it's not free. Any editing application that can create DVDs has some sort of MPEG-2 encoder in it. One of the most common MPEG-2 encoders on the Windows platform is from Main Concept, which you'll find branded in video and DVD products from Adobe, Sony, and ULEAD, for example. MPEG-3 was the next format standard developed by the group. Not to be confused with MP3 music files, MPEG-3 was originally designed to handle HD TV signals with data rates of between 20 and 40 megabits per second. But it turned out that MPEG-2 could be extended to handle those rates, and MPEG-3 became unnecessary. MPEG-4 is designed to deliver DVD quality video at even lower data rates than MPEG-2, with the only catch being that you need a lot more processing horsepower to decode the stream. While the MPEG-4 specification contains all kinds of parts that support 3D objects, sprites, text, and other media types, the really interesting part of the spec for digital video producers is Part 10. MPEG-4 Part 10 is also known as Advanced Video Coding, AVC, or H.264. H.264 video can hit quality levels that are equal to DVD video at nearly half the data rate, which is absolutely remarkable. At least part of the reason for this is that the H.264 B frames can reference up to 32 other frames in a group of pictures. H.264 also does much better than MPEG-2 at lower data rates and frame sizes and is very streamable, making it ideal for web-based video and even cell phones. And H.264 scales up to HD resolutions as well and is part of the spec for both Blu-ray and HD DVD. Pragmatically, we've seen variations of MPEG-4 pop up in lots of places, from QuickTime to Windows Media Video, while the Microsoft codec as implemented in Windows Media 10 varies from the H.264 standard somewhat, and indeed Microsoft has codec technology that competes with it. QuickTime, Sorensen Media, Main Concept, and others have all released compliant H.264 encoding solutions. The MPEG committee continues with ever-advanced video standards detailed in the MPEG-7 and MPEG-21 specifications, for example, and I'm sure we'll cover those here as they become relevant in the future. For today, however, that's all the MPEG we have time for. Thanks for watching.